Okay, test. That should be live. Okay. Hello, everyone. Let's see if this works. Why is Twitch saying the stream is unstable? It looks fine here. Let me know if it's look weird. I'm testing a different setup because last time some hardware issues cut the stream a bit short. The issue is I've always been programming on this old laptop of mine, and when I do the edit of code, it's a bit colder in the room, so running OBS doesn't overheat the laptop. It's a bit warmer now, so the laptop was overheating and just like throttling the CPU. So I've changed my setup, and now it's my gaming computer running OBS using a capture card, so it should not crash the stream even if the laptop is overheating. So that should be better. I'm just not sure why Twitch is claiming that my bitrate is unstable. If anything is weird, let me know. I'll try to fix it. Maybe just some OBS settings that are wrong. We'll see. Anyway, hello. So, welcome back. Let's go back to some more compiler in Haskell. Before I start, just a few quick words I wanted to start with. First, one of you, I don't know if you're here, advertised the project on Reddit, on the Haskell subreddit, and I just wanted to say thank you. I considered advertising the project there, but I felt like it was not my place to do that, and if you thought it was worth advertising, I really appreciate it. Despite the comments, it's kind of like sad to see like the level of comments on Reddit being 4chan worthy. It's kind of sad, but I still really appreciate people advertising the stream. And also, I've missed a notification last time. Scrimmage 91. I don't know if you're here. I really appreciate the subscription. I'm sorry I missed the notification. And also, I really want to stress, as much as I appreciate it, I'm not expecting subscriptions. I have on purpose not engaged with any of the Twitch features like bits and ads and anything like that, because I'm not making this project like as a source of income. I'm making it for fun. So I don't want to encourage people to subscribe and like send bits or anything like this. I nonetheless really appreciate it. Last thing before we get back to it, I wanted to talk quickly about organization stuff. I've changed the schedule to be every Tuesday instead of being every Monday, and I'll try to do most Thursdays, but I can't guarantee that in advance. And last but not least, as I've mentioned last time, there is no deadline to this project. The goal is the journey, not the destination. And as a result, please feel free to ask questions. Please feel free to interrupt me if anything I say is not clear. And with that out of the way, well, let's get started. And yeah, the bit rate seems to be a bit low. If anything is off, like sound, image, let me know and I'll try to figure it out on the fly because we test in prod. Okay, let's go. So, last we left off, we were in the process of finishing to implement the Lexa, so the part that segments the input source code into a series of tokens. We had defined our token type. Not here. Where was that? Tokens. It's not open. Presentation tokens. We had defined our long list of different tokens that we support, and we were in the process of writing the Alex file, which is the Lex Flex equivalent for Haskell, to generate, like to pass tokens. And the main ugly thing was this thing where we already like skip white space, where we have a second regex here that match 0 or more white space, which will only ever match when none of the others match. And so that is so that we can pass identifiers, which will be Unicode strings, because Alex by default does not have like regex for classes of Unicode code points, and I don't want to write a regex that matches any character that Unicode considers a letter. So we're doing some ugly things. One quick thing I want to change, however, is here I had started making decimal literal, hexadecimal literal, and here for the sake of just like doing things on the fly, I was making a string out of the text and just reading it. Read is a partial function that panics on error, and in theory, if this code is correct, we will never encounter a text here that is not just made of numbers, so read should never fail. Nonetheless, this feels unelegant, so I'm going to change a few things. Specifically, I'm going to import data text read. There we go. So that I can, instead of doing this, do a, I think it's decimal. Yeah, perfect, decimal and hexadecimal. There's no syntax highlighting here because I'm in the Alex file, which is not recognized as a Haskell file, despite the fact that between those brackets, this is Haskell code. So here, either we manage to parse the int value. Maybe actually write int value, I think, because it's an either. Yes, it's an. Oh, interesting. It gives me the remaining text. So here, what I want is I want to match remaining, and this is supposed to be empty. Would that work? Probably not. So let's do that. So if there is no remaining text, that's perfect. And when we successfully pass a number, we can return what we had here, which is a literal int with the int value. And otherwise, I wonder, no, I can probably make it with a guard, I think. And I want this to be t.null remaining. Only match this case if this condition is true. And in any other case, regardless of whether we got an error or not, for now, I'm just going to use the Alex error, which doesn't take any argument. We'll do a bit better when we start like doing proper error handling. Specifically, what I don't like about this, beyond the fact that there is no error message, is the fact that I'm using the same function to report errors that come from like the user has input the wrong thing and errors coming from like there's a bug in the compiler. If we ever encounter this, it means a function we called here was applied on text that doesn't match the regex. Like it signifies something when wrong on our side and not the user side. And I will probably want to replace this kind of error handling that like signals to the user something went wrong on the line with like, no, this is an actual internal compiler error. So there's probably going to be some things to do here to improve this. For now, this is probably going to be good enough. And we can do the same thing here, except this is this. Okay. Next. Yeah, it's still saying that the bit rate is a bit unstable, but it seems to be constant at 6,000. Let me know again if something is a bit off. I'll try to fix it. So this is no longer required, and I was as well in the process, since I'm not using any of the Alex features like start values, start codes, or any of that. I'm just basically the second I encounter a character literal, string literal, or identifier, I just write the Lexa myself rather than using regular expressions, basically. So I wrote those functions last time, but they require functions like expect or try that I haven't actually made yet. I had started moving them here when the stream crashed on Monday. So let's go back to that. I was on the fence on whether I should name them Alex something, which is the convention of like what Alex expects or outputs. But I think it makes sense to like distinguish them from other functions I might need in another context. So I'm going to keep this. So Alex expect is going to take a character as input, and will try to pass that character, will report an error if it fails. And I'm going to remove all of this that I wrote last time, because instead I'm just going to make use of the Alex function I already have, which is Alex get byte, which is one of the things that are required by Alex to be able to function, which is basically I'm like the input. Alex is agnostic. I forgot a character. I did indeed. Thank you. Alex is like independent of the type of the input. It works on string, text, byte string, anything. And as a result, either use a wrapper that like knows about the type of input, or you just write your own. And I just basically copy pasted this one from the documentation so that we could make our own internal state management. And here's why I'm saying the problems with Unicode and Alex. Alex functions byte per byte. It always takes one byte out of the input, which is fine for most of our things because there is no Unicode in any of the things that we're doing at the language grammar level. It's the reason why I'm doing something else for identifiers. So here, what I'm going to do is I'm going to do an expect. When I'm doing an expect, rather than redoing this logic myself, what I'm going to do is I am going to get the current state of our parser. So current state, which is going to be with just get. I'm going to call Alex get byte of that parser state. And that's going to give me either nothing, end of input, or just the character that we just passed and the new state. Importantly, since like nothing is mutable by default in Haskell, here the state is not, the underlying state is not modified, it just gives me the new one and it's up to me to decide what I'm going to do with it. So here I'm just going to do a case here of if we get nothing, then that's an error. For now, Alex error doesn't have any arguments. Again, we're gonna need to do some better error handling at a later point, but like that's an error. We were expecting a character and we got the end of the stream of characters. If we get instead a byte and a new state, here what we can do is two things. If the byte is equal to expected, except this is a word 8, this is a character, so I'm going to need to do a character out of from integral of the byte. If that's the case, then perfect, we can just return nothing. And otherwise, we're just going to do an Alex error for now as well. Okay. And try is just a parser of a boolean that tells me we successfully passed. Can I rephrase expect in favor of try? Yes. Actually, I'm gonna redo this because just Alex expect is just Alex try and checking that we have a boolean true. So here this is, if we didn't get a byte at all, then this is pure false. We did not return the thing we wanted. Here, actually, I could even just do a pure and return false directly here. No, actually, I can't do that. Because here, just byte new state, actually, how do I do that? Because here, in this case, we're like pure false. If it's different from expected, we didn't match the thing, so I don't want to change the state. I don't want to consider this character as parsed. Otherwise, if we do successfully parse the character, I think I want to update the state to reflect the fact that, like, no, we have successfully parsed the character. I think that's correct. So here, what I want to do, so here in the case where it's different, I'm returning false. But in the case where it is the correct character, I think I want to put the new state and return true. I think that's correct. And now if this is, I can just do there is, which library does give me that? There is an unless m, I think. Control monad extra in extra, perfect. Do I have extra in my dependencies? I do, perfect. But not in the library. Okay, I'm gonna put it here. And here I'm just gonna need, was it control monad extra? Yes. Okay, so now I can do an unless m of Alex try of expected. So if we try to pass the thing and we fail, then in that case, what do? We do Alex error. Okay. That should be fine. So if we go back here, Actually, I'm gonna do a quick thing. I'm gonna introduce a type alias. An Alex action is gonna be something that, given the location at which the thing occurred, the text of what we passed, return a parser of a token with location. And actually, I'm going to change this. I'm going to remove the with location type for reasons I'm going to explain later to make it a tuple, which it already is anyway, so it's not a big difference. So here, make token is something that takes a token, returns an Alex action. And I'm just going to replace everywhere this with Alex action. There we go, a tiny bit more readable. So here, that's basically the same thing. Again, our error handling is bad, but something we're going to have to do later. So here, for a character literal, we expect one string character, which is a function we don't have yet. And again, I'm going to prefix it with Alex, I think. And then here, after we're done reading one character, we are expecting a closing quotes, and if we don't find it, then we should fail. There's an error of syntax, and if it succeeds, then yes, we need to have parsed it. That's fine. And if this worked, then we return a tuple, the location, and the literal character. Perfect. And for strings, that's basically the same thing. And here, I'm going to replace this with an until m, I think. Yes, you're absolutely correct. Thank you. The compiler would have notified me of this, but yes, you're absolutely correct. Here, I think I'm going to replace this rather than being like, this is already wrong because it was based on the assumption that this try would actually return a maybe thing, which is no longer the case. I think I'm going to change it. There is a while m or something, which is also in control mode extra. Perfect. And I think it's an until m or something. No, while m is correct. No, it would be an until m, basically. I want to continue running the thing until try reading a closing bracket tells me true. So is there an until m in there? No, there isn't. That's fine. I can do a while m and just negate the result. So read string cars is going to be while m of not Alex try closing bracket. So as long as trying to read a closing bracket fail, perform the same monadic action, which is going to be I'm going to copy the name from here. Actually, no, this doesn't work. Is there a way with while m to collect the result as a list? No, there isn't. Is there? The loop m actually gives me something that I want. Maybe there isn't a good way to do that. That would be more of an accumulator. Let's see if Google has the answer. I want something that, given a monadic boolean and another value a, and some... Wait, no. I want something that, given a monadic boolean and a monadic a, gives me a monadic list of a. Oh, well, m. But okay. There is the until m, which is exactly what I wanted. But that is in another module, control monad loops. Okay. Let me zoom this so it's readable on stream. until m, execute an action repeatedly until the condition expression returns true, which is exactly what I want. The condition is evaluated if the loop body. Wait, does that mean that... Yeah, I think this is wrong for our purpose because it executes this action first always, and I don't want to do that. I want to start with the condition. So I think it's going to be a while m with... So here I don't want actually to use extra, and then I want to use the other one. And I want to use control monad loops, and I'm going to use while m, which is from monad loops. Okay. Oh, wait, it's actually in this module. Why did I use this one? This one I use the unless, I think. Yeah, I use the unless m. So here in this file, I'm going to keep this as control monad extra. And here in this one, I'm going to import the control monad loops. And I want just while m. Okay, and let's go back here and here. So what we're doing is I want this while m, which is the one of this module, not the other one. And the condition that I want is not of Alex try this, which will only return true if we succeeded at passing the ending quote, the closing quote, which means as long as this doesn't tell me true, we want to execute a thing that gives me a character, and the action we want to execute in the loop, we don't even need to do anything more than that. It's just Alex read string character. And this is going to give us a list of string characters, which is a list of characters, which is a string. And here, literal string, I think the only thing is our token definition. This is text, so I'm going to need to convert that string back into text, which is going to be a pack. Okay, there we go. That should be all we need. The last thing to do is to define this Alex read string character function that I have not defined, and which is going to be somewhat similar to... I'm not writing a compiler for Haskell, I'm writing a compiler in Haskell for a made-up language that is basically a subset of Rust. And like very similar syntax to Rust, very different semantics, because the target is not to actually compile to a binary, it is to compile to an esoteric language in which the source code is an image, which has only a stack, so no heap, no pointers, no nothing. We are very limited in what we can do. Hence the restriction on being a very simple language that we're trying to pass. But the goal of the exercise is to be as close to a real compiler as possible, hence using actual proper like Lex and what's the name of happy in C, C++? Is it, I think it's Bison for C++ and it's Yak for C, I think. Like trying to stay as close as possible to real compiler implementation, despite the fact that the language we're starting with and the language we arrive at are neither of them is actually practical. And yes, I'm only missing one thing, which is this Alex read string character, which is going to be something that gives me a parser for one individual character. What do we do with this? The thing is, we basically want to accept anything that's not... Wait. We are going to be running into the limitation of Alex again. This is going to be this function here is going to be giving me bytes. So maybe instead here, instead of like trying to treat this as characters, I should treat this as bytes. and therefore treats the result here as a byte string rather than a list of characters, because it's not going to be Unicode code points, it's going to be individual bytes in there. Or I, instead of reusing the Alex function that gives me the next byte, I assume that since I'm reading characters, I was in the case where the previous character had no leftover bytes because it was just the ASCII double quote, and therefore I can ignore this and just take from the actual raw text directly and get actual characters. That's probably what I should do. I'm also realizing that this position thing is wrong here, because this Alex get byte assumes that we always advance by one character whenever we encounter a byte, which for Unicode values is just not true. Again, the limitations of Alex being pretty obvious here. There might be a way to fix this at some point. I'm actually going to put a comment for now to do only increment position if bytes is empty. I think that's correct, as in we've read an entire character, we've finished reading a character, there are no more bytes in it, and therefore we can advance the position. I think that's correct. Okay. I probably actually just want to use this function, which means which means I'm going to need to change this to actually here not being, hey, this is a list of characters that we are making into text by converting from string. This is going to be a list of bytes. Let's go to the byte string documentation. And let's see if there is can I construct one of those from a list of characters? Basic interface, let's see. From list? Is there a from list? There isn't a from list. Huh. There is no way to convert from a... No, there must be a way. Okay, Hugol to the rescue again. I want something that, given a list of word 8, gives me a byte string. Pack, there we go. That's what I was missing. Okay. So list of word 8 into a byte string, and then, because yeah, string types in Haskell can be a bit of a hassle. Now I can then, when I have a byte string, I can probably find in text something that converts a byte string into a text, which would be the encoding. And we are assuming UTF-8. So decode UTF-8. There we go. And this is a byte string. Perfect. Okay. Is it worth going through all this hassle and dealing with encoding and bytes and everything? Maybe I should just instead pass the actual input character per character, since I don't need to rely on the Alex primitives, and therefore it avoids this whole juggling the different representation of strings. Yeah, I think the upside of reusing the Alex function is I don't have to duplicate this logic, but a lot of this logic is dealing with bytes, which is not the thing we want to do anyway. So I think I'm just not gonna use this thing, and I'm actually just gonna make it myself. So we're gonna get the current state. And I'm actually gonna decompose it here. It's a parser state with a bunch of fields. And that way I can actually, I'm gonna do even better. I'm gonna do get next character. And now we have two things to handle. Either C is a backslash and we need to handle escaping, or it's not, and we can just return the character. Actually, I'm just going to do it differently. I'm going to say if it's not backslash, then just return that character. We don't need to change anything. And otherwise is where we're going to have to do we're gonna get the next character and handle the escaping something. So pure undefined for now. And get next car is going to be something that does what I was doing before, given our parser state that we get from the underlying state, and that's the current. I'm going to put the definition of parser state on this side for now, so that we can see what we're dealing with. There we go. Here, our parser input is going to be the text that we want to take the next character of. Actually, I need to handle the case where it failed, I suppose. I guess I don't have to. I guess this function can just like error in case of like we're trying to get a character and we didn't find one. Yeah, and so that. So here, let's unconst the text, which is our parser input. And if it tells us nothing, that means there wasn't any character left in the input. That's an error. That's an Alex error for now. Again, we're going to have to redo errors at some point because this doesn't even take an error message. It's just going to tell me like failing at this position, which is not great. Otherwise, it gives us the first character and the new state. Sorry, the new text, the remaining text. In which case, what we can do is we can update the state in the same way that we do that here. We are gonna do that. We are gonna put back in the state the current state, modified by using those lenses. The location is gonna be modified by being update location. There we go. Update location. There we go. The new input is going to be what's remaining after like popping the first character, and the previous character that we passed that we might not actually need, but for now we're still handling because Alex requires for some of its features to have access to the previous character we matched, because we can express regular expressions as being conditional, like we only match this one if it appears after this other regular expression. For that feature, Alex requires knowing what's the previous character we passed. We are unlikely to need that, so I could just get rid of this previous character field altogether. But for now, I'm doing it properly. We'll clean afterwards if it works without it. Okay, so here we've successfully passed the character. We've updated the underlying state, and we can return our character that we passed. Okay, so here we get a character. If it's not a backslash, perfect. That's a normal string character, regardless of whatever it is, and we can just return it back. Otherwise, we need to handle what comes next, basically. what do we do? So yeah, we get the next character. And I'm just going to immediately bind it into a case. And what did our reference said we would actually handle? Character. Okay. So that's the list. It is also set incorrect because there's one thing where I'm doing different than from Rust in terms of handling white space. I'm handling white space the way Haskell does, which means if you're doing a multi-line string, a backslash at the end of a line before a new line character will escape not just the new line, but until the next backslash, which allows you to not have to put everything at the beginning of the line, but you can indent things without having to include all the white space, which I really like. So we're going to have to handle this as well. So I guess here it's going to be, if it's X, we need to handle ASCII character, which for now I'm just going to leave undefined. If it's U, it's going to be undefined handle Unicode code point. If it's N, that's easy. That's just a new line, in which case we return the character we have passed, which is indeed a new line. And for those, it's going to be easy because it's just if we encounter that character, we return just that character. Yes, double quote, we don't need to escape because we're returning the individual character. Single quote, yeah, that's correct. This is backslash 0, T, R, I think that's all correct. And there's the last case we need to handle, which is when we encounter an actual new line, which is where we're going to go skip until the next backslash. Okay, is that correct? We try to read a character from a string literal or from a character literal. If it's not a backslash, then we just accept it because we already have something in place to test for closing characters before that. And otherwise, if it's a backslash, then we handle. No, there's something that's wrong here, but not in this function. I can see one edge case that's wrong. Here for a character literal, if I cannot distinguish here just purely on the return of this function on whether I encountered a single quote that was properly escaped or I encountered a single quote that was not properly escaped. So I should probably here handle that case explicitly. I should do an Alex try of an actual closing quote first. And when that tells me true, then I can report an error. because that's not supposed to happen. We're not supposed to encounter an empty character literal. That makes no sense. Then I can do this and then expect the closing um, single quote. There we go. Okay. Now we're just missing defining those. I'm tempted to not define them for now, just so that we can make progress to the point where we can try to compile Alexa. I think that would be good, so I might not bother with this for now. However, the last thing we do is we need to handle the identifier, which we have not done, which is going to be somewhat similar. So what are we going to do with this? We are going to take characters as long as they are a letter or underscore or a number if they're not the first character. There's no escaping here, so we don't need to handle the same logic here. But I could use this function that just gives me the next character, basically. Trying to think of like how to handle this. Because I don't want to reuse those functions, because I don't want to deal with individual bytes, because that's the whole point of handling identifiers manually, is to be able to handle Unicode code points and not have to worry about individual bytes. At the same time, I want to basically try to do a thing where, like, maybe I'm just gonna have to write it manually. I want to only get the next character if it is a valid character for an identifier. Yeah, I think I'm just gonna remake a function for this, just not trying to reuse existing stuff. Okay, so we're gonna need an Alex read first identifier character, which is gonna be just a parser of maybe character. Actually, no, this one is never supposed to fail, so it can be just a character that will just like report an error if we fail to do that. And then I'm gonna need an Alex read identifier character, which in turn will be a parser of maybe character, where we are gonna return just a character if we found something that continues to be a valid identifier, and return nothing if we found something that is not a valid identifier character. Okay. Those two are gonna be fairly similar, I suppose. So I might use some common function between them. Maybe this get next character thing. Well, except no, because I don't want to unpack, I don't want to make the character, I don't want the character to be passed if it is, I guess I could actually. I'm gonna rename this one as get matching character. That's gonna take as argument a function from character to Boolean and return a parser of maybe character. And here, so like that's gonna be our predicate. We're gonna do the same thing here. And here, when we match a character, if the predicate for that character returns true, then we can do this thing where we update our parsing state and we return the character we found. Otherwise, the predicate did not match, that character was not one we were looking for, and we can return nothing. Okay. That means that here for this function, get next character is going to be it's going to be a get matching character where the function is const true. Always return true. We accept any character, but we still need to handle the fact that like it might be nothing, even though in this case it will never be, I think. And I think I have in my custom prelude, which is here, I have a function for this. Where is it? On nothing, there we go. On nothing m even. So on nothing m, if this thing returns a maybe not like a monadic nothing, we just return an Alex error. Okay. So that way we can have a function that only pops the next character if it is if it matches. So now those two functions are just going to be a get matching character. The difference is going to be what do we accept as being a valid character, basically. So this is literally just get matching character with a predicate for what a valid character is. And that's going to be a function. What did we do in our reference? Identifiers. So underscore, letter, or number if it's not the first character. And I think if we go to data character, because I know the is letter function here is any Unicode character that is considered a letter, which is good, which is what we want. But is alpha num note that numeric digits outside the ASCII range, as well as numeric characters which aren't digits, are selected by this function. Yeah, that's perfect. I think that's correct. So this is basically a character C is valid as a identifier character, as the non-first identifier character, if it is alpha num C or C is underscore. Perfect. And for the first identifier, it is letter, or just I'm going to use alpha just because the two things are the same. Actually, here I'm going to have to do something else. I'm going to say predicate on nothing m Alex error, where the predicate for a character C is alpha or C is underscore. And here for the non-first identifier character, it is the exact same thing, except we don't need to return the on nothing because it's okay to return a maybe character. It's not a failure to not read a character that's not an identifier. But our predicate is slightly different because now we accept numbers. Okay. That should be fine. And now we've equipped with those functions, we can go back here, and reading an identifier is reading the first character, which is Alex read first identifier. And then we're going to want to do the same thing where we are going to want to do a collection of like while, except it's not the same this time. Let's go back to control monad loops. I think there's a while just. While just, given an expression That's not exactly what I want. I mean, I could make it work. Oh, there we go. Unfold M. That's what I want. Given a function that returns a monadic expression that evaluates to a maybe A, repeatedly call it and give me the list of A's for which we return the just, which is exactly what we want. So what we want to do is here remaining characters is an unfold M of Alex read identifier character. There we go. When that's done, we've read all characters that make the identifier. We've erred if the first character was not a valid thing, because when we enter this, we know we need to be reading an identifier. The state has been updated underneath by those functions and by the get matching character thing we've made here. So now when we are at this point, we have a list of characters, and the last thing we need to do is to return. So actually this takes as an argument the location and the string we match, which will always be empty. In this case, we don't need it. And here we can return a tuple of the location, as always. And how did we call our token? It's t-identifier. And its argument is going to be a text, which is going to be the pack version of the first character at the beginning of the remaining characters. And we need to close that tuple. Okay. And now that should be everything we need for our Lexa. Well, except, I haven't handled all of the... I have not handled all of the escaping codes, but I think for now that should be enough for us to actually get to the next phase, which is compiling this. Because we haven't tried to compile this basically since the project started. So we should probably try that. I don't know why the bit rate is... You just give me 1 second. Maybe if I just put it a bit higher, if I put it at this value. Trying to increase the bit rate and see if that makes Twitch happy. We'll see. Twitch keeps saying that my bitrate is unstable at 6,000. That's weird. Anyway. Okay, so now we have here everything that we need, in theory. There's one thing we haven't done here in tokens. This badly needs documentation, but it doesn't have that for the moment. I have here introduced identifier, but I have not made a type for this. And I think for now, although I might change this later to avoid issues, for now identifier is going to be just text. But I will probably want to change that at some point. That's not the definitive version. And location here, I'm going to remove this with location for reasons I will explain when we get to making the AST, hopefully this evening. Okay, so now it's going to be time to compile all of this and to see that it absolutely does not compile. That's fine. Okay, so what do we get? We get an error here, that's fine. Make identifier. Warning, regular expression matches the empty string. I know that's on purpose. So that's a warning that we're going to have to figure out how to remove because that is deliberate. I want to match the empty string on this one. And note in scope, text, yes. Now in scope, file path, because it takes a capital P. There we go. Yes, make lenses position doesn't exist anymore. It's called location. Initial position file path with the capital P. It would be more consistent for this to be named location as well. There's one thing where I haven't fixed the code and I already know that. So I should probably file name. Actually, do I ever use the parser file name, or is it only ever used for the current location? Git grep parser. I can't type parser file name. No, I don't seem to ever use it. Maybe I don't actually need to store that, since I already have it stored in the location. But originally I didn't have it used in the location, so maybe that's why I was doing this. Yeah, okay. I'm just gonna remove it from the parser state. I think it makes no sense there. So no need for the parser file name. No need for the parser file name. It's gonna just be given here in the location. Okay. And there's one thing I haven't done. I know it's wrong, and it is in the happy file, actually. Because I've used a thing where the parser can be configured to know about the lexer. So instead of like lexing the entire file into a list of tokens and then running the parser on the list of tokens, the parser knows how to call the lexer to get the next token and just calls the lexer whenever needed, which means we don't need to traverse the whole thing twice. And here at the bottom of this is the function that we give the parser so that it knows how to call the lexer. So like given a continuation function from token to parser of A, like return the new parser of A, which is the monad in which the parser operates. Actually, I'm going to change this. The token type is no longer token. It is a tuple of location token. So this needs to be changed accordingly. This is location token. And here, the only thing that's going to change in case we encounter the end of file, that means I need to just return. Oh, that's going to be annoying. I need to return here. The location is the location that we had in this current state, so that's going to be parser location of current state. Syntax highlighting being very wrong for this is a bit annoying. Okay, in the case of an error, we just do that. We update the state and we call Alex error. That hasn't changed. In the case of a skip, this hasn't changed. We update the state and we actually, I'm just gonna make it as a do block. There we go. That's also a do block. In the case of a skip, we update the state and we call this function recursively to get the actual token after something was skipped, because we only skip new space, white space. And then finally, this is where I actually need to change the things. So here is where we actually, encountered a token. One of our regular expressions matched something. So now we do have here that's an action, that's no longer a token, and that's where we need to do a few things. We are going to have to call the callback function, but on a location and a token. We don't have token yet. The location will be likewise the parser location. Oh, this is annoying. The parser location of some new state. But the parser location of that state will be the one after we call the action. So here what we're going to do is we're going to call the action. Actually, if we call the action, it gives us the location and the token. So that's perfect. Because the action, its type, as we have decided here, its type is takes the location, takes the text, returns the parser location token. Ooh, actually, Actually, do we handle location properly for the things where we read more than one? Nope, we don't. Because, actually, no, I think actually that's fine. The location of a token, it will be the start of the location. I guess if we were to change this to be a range from like starting character to end character, we would need to change this. But saying that the identifier, the character, the string literal author at the first character, I think that's correct. So maybe I could change all of those functions to not take the location and return the location and just add the location afterwards. I guess it doesn't hurt to do it that way, because that way, if I ever change anything like this, well, now all of those functions have the ability to manipulate the location, although they're all just going to return it unchanged. Yeah, I think it's fine to keep it that way for now. So we are going to need to get the location. So location is going to be, I'm going to do a use of a lens of in my state, which is the parser location. And then with this, I'm gonna want to get the actual inputs. One sec, let me think. Let me think. Here, actually, I probably want to do the thing where I get the entire state. Actually, I think, to do this before I put the new state. That's tricky. Okay. Because here, this new state will be the state after passing a character successfully, or more than one character successfully. Therefore, it will be one in which the parser state no longer contains the thing that we matched. So if I want to actually pass the thing that we matched to the thing, I need to extract it from the state before this new state. So I think I need to do this current state, which is a parser state with a bunch of fields in it, by doing the get on the underlying state before. Actually, I already have it as current state here. Okay. So maybe I can just say this is a parser state of this. There we go. Because I need to look at the state before I passed if I want to get the text that we matched. Because the text that we matched, so the location is going to be just going to be parser location, basically. And now what I want to do is I want to get the matched text, which is take len of the parser input that we had in our input here before, because we matched n. Oh, please tell me those are characters, not bytes. They're probably bytes, but our grammar is such that outside of identifiers and string literals, we should not be encountering non-ASCII code points. So I think this is fine. Famous last words. We might have to check this. Because if it doesn't work, I'm going to have to convert this text into a byte string and then decode it from UTF-8 again, assuming the encoding. Yeah, okay. I'm going to assume that since we are here, it means we matched one of the Alex regular expressions, and therefore it means we're just using ASCII. We don't have to worry about the character byte distinction. Okay, so here we extract the matched text, and now we can call the action, which is our Alex action, which takes the location, which is the parser location before passing successfully the action. That's correct. Then the matched text as argument. And that gives us a tuple location token. It gives us exactly this thing. So we can just bind it into f, the callback function. Okay. Let's go back to compiling things. Update location. It probably... Oh, because I did not rename it. It's still called update position. That's a mistake. Let's fix this. Here, the data constructor location should have 4 arguments. Okay. So that's the file name first, if I remember correctly, and then it's address, line, colon. Yeah. Okay, actually, I could change this to be file name plus show line. This is a very inefficient way of building strings. Again, we're going to want to do things better at some point. Up. That way we will have the standard file name colon, line, colon, colon, so that we can then have like stuff like Emacs that like try to pass errors will try to give us a proper error. Now let's do the same thing for happy because we have the same problem here. File name, line, colon, parse error. And I'm just gonna do for now a show of the token. Which is not gonna be a very useful error. We'll have to improve that at some point, but not for now. Okay. I did not import data.character. There we go, that's fixed. Pattern matches are non-exhaustive. Yes, that's correct. Here, when we encounter another escape character, we need to just report an error, like this is not a valid escape character. Alex error. Okay, now we're getting into the actual part here. Location is undefined. I need to include representation location. When M not in scope, I think when M is actually from control monad extra. So I'm going to have both of them in the same file. And unfold M is from the loops. Okay. Matches the empty string, we know, that's correct, it's fine. Okay, here there's one error that's in the first argument of unfold M. Yes, because I have made a typo here. This is Alex read first identifier character, which is incorrect. It should be the other one, which is called read identifier. Identifier, not first. Okay. Okay, here in this parser that we have not written for now, our grammar is just a bunch of statements, so like nothing will parse. I want actually to redefine this. I'm going to need to have a look at the happy documentation. This is representation. I need location here as well. Yes, now this no longer exists, so this example here no longer works, so this needs to be this. We're missing one last thing. We are missing data.text qualified as T. This file's not supporting proper Like syntax highlighting is very annoying, but we should be mostly done with them now. Yes, take with a capital T is incorrect. This would be take with a lowercase t. There we go. Okay. And the pattern TEF. Aha. That I don't know how to do. Is this correct? Is this, yeah, and likewise here, this is gonna be a location that we don't care about and a keyword const. Is that correct? Nope. What is wrong here? Ah, yes, when we call a happy air, it's giving me a token. So that means here in monad, when I get a happy air, I don't get a token. I get, as everywhere else, I get a tuple location token. That means here I can decompose this here in the argument and throw the air. There we go. We're getting closer. What is wrong here? Okay, so here my lexer function is slightly off. Yes, of course. That's in parser here. Here I'm applying the parser location function to current state. However, since we have this here, this introduces a location in scope with that same name. So this is what I need here. And that compiles. So let's go with 2. I just need to have a quick look at the way to call, since in this case we're gonna want to call Alex directly rather than relying on happy to call Alex, because we have not done the parser side of things. Let's have a look at how. Good evening. The debate of like what do we call magic is some fictional universes that have both magic and science decide that like the defining character trait of magic to distinguish it from science is that it does not obey rules and it's all vibes. And as a result, here, this not being vibes and all being rules, it would not be magic. But, arguably. But I think it's a debate I'm not qualified to answer. Okay, so how do we actually call Alex when we are not... Alex scan, was it? I saw briefly that on screen. No, Alex scan is the function I'm calling that gives me this. It doesn't Alex give me an actual proper function that scans the entire thing? Huh. Well, on that note about electricity, there is a thing that's absolutely excellent called the NAND game, which basically makes you start with like just one simple NAND gate, a very simple, practical piece of like metal with like electricity comes here, it toggles this metal thing, and it connects electricity or not. Most basic physical thing you can imagine. Okay, now with this, you can combine it several of them to make an AND gate, a NOT gate, an OR gate. Okay, with several of them, you can make a latch. With more latches, you can start doing registers. And basically, starting with just this little, like, small piece of, like, metal thing, you end up basically remaking a compiler from scratch. Fantastic little game in browser. Strongly recommended if you want to, like, build an intuition for, like, how does, like, electricity and metal end up making computer, Oh, scan tokens. There we go. But that's, I don't know if it's something that's generated in the case where we have a wrapper. Maybe we're going to write this function ourselves. Maybe for the purpose of debugging, for now, I'm going to include here I'm going to include an Alex scan all that, given some text, some input text, is gonna give me, given some text is going to give me the full list of tokens, which is a debug function that we might use in tests. Okay. So what do we do with this function? I've copied the thing that they've made, but I think it's incorrect for us. What we're going to want to do is initialize the state. So I'm going to have a quick look at how I did that here in parsing.hs. Oh, it's not even there. It would be here in run parser. Okay, initial state. There we go. Takes the file path and the source code. Perfect. So Alex scan all will be something that, given a file path and the raw source code, is gonna give me a list of tuple location token. So what we're gonna do, this is gonna be a run state. I can just do a run parser, I guess, since I already have this. It's gonna be a run parser of a parser, file path, and text. So this is just run parser go. I cannot recommend a better thing for like trying to understand a topic than just trying to make one. Like, there is no better way to understand compilers than just trying to write one. There's no better way than trying to understand an interpreter than trying to make one, because you'll run into a bunch of problems that people before you have already encountered, and that's how you learn how to overcome those problems. Okay, here, what do we do? This is gonna be, I guess I could do one of those like iterate m while m kind of thing, because this is gonna be basically give me a token until we run out. So this is gonna be a run parser where our action is gonna be a unfold m of go, I guess. Go is a very common name for like when you have a function, usually recursive, declared locally. In this case, it might not be recursive, but it's fine to do this like this. Although I could just declare it in line, actually. No, because it's probably easier that way. No, actually, no, I could just declare it in line. This is unfold m of a monadic action, which is gonna be current state is get, and case Alex scan of our current state, and 0 as the start code, because we are not using start codes. As when we encounter an end of file, we return nothing. When we... No, actually, we need to call it go because we need to be able to continue to do a thing recursively. So this is indeed a run parser of unfold m of go, because in the case of a skip, we need to be able to call it recursively. So this is that. Pure nothing. When we encounter a skip, we put, so that's new state. That's new state the length we never care about. That's the action. And here, when we encounter an error, what's that? That's the new state. I'm actually gonna use the new state in this case. Okay, so in the case of an end of file, we return nothing, we're done. In the case of an error, we put the new state and we call that X error. In the case of a skip, we put the new state and we call go again. And in a case of a token, I'm going to actually copy this from what we've done for the other one, which is parser of the Y. Where are you? There you are. I'm going to actually, yeah, this is basically the same thing, except I'm just going to copy this. Here, in the case of a token, new state with length action, here we're going to do okay, put the new state, get the match text, call the action that gives us a maybe. Does it give us a maybe? What does it give us? It gives us a location token. So in this case, we can do a just in the result of the action. Okay. Is that correct? Let's see. That's annoying. Okay, those functions are, this relies on the LX file, which is generated and imports this one. So I can't put this here. I need to put it somewhere else. I'm gonna put it here and I'm gonna name it differently as a result. So this parse function, I'm gonna change. I'm gonna call it lex. Okay. Oh yes, let me quickly change the thing I wanted to change while I'm at it. Here, while is this one called parser? It's called parser because here, that's what I've named it. And there is a way to change this, and I don't remember the way that works. So let me quickly have a look at the happy documentation. This is the name parameter. There we go. Name parse one non-terminal one. Okay. So perhaps parse file takes a file. There we go. And now this would be run parse file. Okay. This is gonna require a few things. This depends on this gonna depend on the lexer as well. And this might need, no, I don't need the location in here. Okay. I need the location in here. And token. Tokens? Why did I name that file plural? Huh. So this file here, I have in stages, I have a parsing subfolder and a parsing HS file, which is basically the interface for the stuff in the parsing subfolder, a somewhat common pattern as well. And here I need the unfold M, which is, as we've been saying, a control monad loops. There we go. Yes, this gives me either a parse error, which is just a string for now, or the result. Okay. Now we have a lex function that does what we need. So here I can reload my GHCI session. And what happens if I lex a file path which is interactive for now? What do I try to pass? Let's try to pass function main, which takes no argument, returns nothing for now, and does... What does it do? Let a equals 3? Ah, yes, there's more than one function called lex. Let's give it a name so I can do this. Aha! Lexical error on line 1 at character 25. So this let is incorrect. Okay, so let's start smaller. What happens if I just scan this? Lexical error. Okay, so I think the end of file is not recognized properly. Oh, that's because I know why. That's because, and that's why there's a warning, and I don't know how to fix this. That's because here, this parses, not like this accepts an empty string, therefore we never match the end of file. I think that's the problem. So that means here I need to not match the first, like an empty string. I need to match the first character, which means I need to match any character and do the verification afterwards, basically. Let's change this. So here, this is the first character. And here what I need to do is, unless... Actually, this first character is a text. So I need to check. So I want to do an uncons of this first character. If it gives me just a character C, and how do I test that this string is empty, actually? There's no pattern I can match against it, I think, because this is a text, and I don't think data text gives me a pattern. I could probably make that, actually. View patterns. That's not what I want. There's no pattern synonym for text. Okay. I could consider doing that, actually. I don't remember if I can do a pattern synonym that is just applying a condition on the type. Maybe not. Let's call pattern synonyms. I don't think there is such a thing. Okay. Oh, wait. No, I can. can use guards. Ah, but I need to be able to match in both cases. Huh. Okay, I'm not gonna bother for now. I'll look into it. I'm not sure there's a way to do what I want. What I want to do is basically have a pattern synonym that allows me to say I want to match against the empty text, which I don't think I have a way to do at the moment. That's fine. Because here, what I want to do is if so if there is no remaining text after this, there was only one character in this string, which is correct. And now we can do if like unless is alpha of this character or this character is underscore. No, that doesn't work. That doesn't work because dot is gonna match the first byte. Ah, that's annoying. Oh, that is extremely annoying. Which means if our identifier starts with a kanji, for instance, or like anything that's not just an ASCII character, this doesn't work. Ah, let me think. Because what I want to do is basically something that matches any non-empty. Yeah, I think I want to do that. I want to match any non-empty character, but ideally I would like to get the state as it was before the action and go back to doing exactly what I was doing before, as if I had matched nothing. That's what I want. But given the way it's currently implemented, I always put the new state in place, so I'm past the thing I have matched. I guess there's a solution to this, which is I'm going to change the type of Alex action to also contain the old parser state from before. That's a bit overkill, but that should fix our problem. So here I can ignore the old state. Ignore the old state. Actually, there we go. Also gonna just be renaming a few things for clarity while I'm at it. This is location, this is matched. Pure location, there we go. Okay, so here I need to ignore the previous state. Ignore the previous state. And here is where I need it, previous state. And here I ignore the first character altogether. I don't take it at all. And what I do instead is instead of doing all of that stuff, I pretend we did not match the first byte of the thing. I put the old state back, and then I keep doing this as I was doing before. Okay, that's ugly. That's ugly as hell, but that should work. So here, that means No, it's fine, because since we go recursively, if we skipped white space or something like this, we did put the new state, so the current state is always the one before doing the Alex scan. So yeah, that's good. So here, when we call the action, we need to give it the current state, which is not the same as the new state, which is the old state, actually. And we need to do the same thing here. This gets the current state. Okay. Let's recompile this, and let's see if this fixed our problem. So here, that seems to have fixed it. If we try to lex a string that just contains the fn keyword, we get that at the location of this file name address 0, line 1, colon 1, we have the keyword function. Perfect. Let's try a bigger example. Let's try this. Okay, this is unreadable, but that looks fine. If I do a either undefined, or on the case where I do have something, a traverse print. There we go. That's a tiny bit better. Because it puts one per line. So here at at line 1, colon 1, we have the keyword function. Column 4, we have the identifier main. So our identifier parsing seems to be working. That's good. Then we have a open parenthesis. That's correct. Close parenthesis. That's good as well. Then we have column 1, braces open, keyword let, identifier a, operator assign, literal int 3, operator semicolon, and delimiter braces close. Perfect. So we seem to be able to lex things properly. That's pretty good. There's one thing I thought I wanted to change based on this. Give me 1 sec to figure out what I was. There was one thing I saw while doing this and I was like, this needs to change. No, I wanted to try with non-ASCII identifiers. I have somewhere in my tests, in the unit test, I have the thing for encoding. Let's go. Let's use this one, because that's a letter as far as Unicode is concerned. Therefore, that's a valid identifier for our language. So let's say that this is now a string literal in which the same thing appears. And let's see if we manage to parse that correctly, despite Alex being annoying by doing things byte per byte. Interactive variable not in scope. But that's not... Oh, because, yes. Undefined called at interactive 12.8. Oh, because we got a parse error, so something went wrong. At character 21, so probably 21 was operator semicolon. So something went wrong here parsing this. Let's try to see if actually parsing the identifier is fine if I put something else in the string. No. Maybe it's a problem with just string. Okay, it's a problem with strings. So if I go back to this and I say 0 instead. Okay, so the identifier seems to be correct. It gives me this escape code, but I assume that's the proper character. How do I get the actual character from this? I guess I could instead do... copy this and get the value of this. Okay, yes, okay, so that's correct. So the identifier was correct, which is reassuring. It's strings that we are not parsing correctly. That's interesting. Okay, so let's try to lex something a bit smaller, which is gonna be the string Ooh. Or actually, even start with the character A. Oh, so that worked. Literal character A, that worked. Empty character should give me perfect, and more than one character should give me a lexical error. Perfect. And backslash n should give me literal character backslash n. Okay, so character seems to be working. And if I try with arcng again, okay, so character parsing works. It's string parsing that doesn't work. So what is wrong here? It failed on the very first character. That's interesting. So what's happening here? So when we enter this function, we've already updated the state. So we are on the first character afterwards. Alex try should not update the state if it doesn't successfully. Let's check that. Yeah, it should only consume the thing if we did successfully pass the double quote. So otherwise it should not. Otherwise it should not get the character. So here Alex read string character should give us. Huh. What is wrong in this one? Because we've checked that this works in the case of a character literal. Wait. No, okay. Oh, unless this is not a valid. This must be a valid Alex way of describing. Let me check actually. Interestingly, I don't see the double quote within the list of things that need to be escaped, surprisingly. That seems wrong. Huh. Ah, but here there is like a string cannot contain the double quote. Interesting. So this is probably just not the valid syntax for this. So a rule is. Hello. We have the lexer working, except for string literals for some reason. And that seems to be because I'm using, back quote, like double quotes as the delimiter for things. But it seems that the syntax of Alex is not happy with this. So I'm trying to figure out in a rule the regex here that's defined as. I'm not sure. It clearly seems to suggest that this is not a character that needs to be escaped. So that means I could just type like one of them? That feels wrong. That feels completely wrong. Huh. Surely that cannot be correct. Ah, that worked. So I guess I can put stuff in double quotes if the order matters, but otherwise, if it's just a single character, then double quote on its own is fine. And apparently, the syntax highlighter disagrees, but this seems to be valid syntax. Okay. So now we can go back to our example where we're trying to lex something that contains Unicode characters in identifiers and Unicode characters in the string literals and check that this is correct. Okay, so it passes now. The identifier is this code, which is correct, and the literal string is correct. Perfect. So that seems to be working. Let's just try with more than one character at a time, just to make sure that the weird byte handling of Alex is not messing anything here. Although we know that the location is going to be wrong, we have it to do for this. The identifier is indeed C character D, and the string is B something A. Perfect. Okay, so that seems to be working. Our Lexa is working. Let's commit this first. It's probably not very readable. Let me do this. There we go. Okay. So what are we gonna commit here? Do I want to make only one commit that actually compiles all of this? Because what did we change? We added a type for the identifier. We fixed a few naming issues in location. This I can commit separately because it adds a debugging function. Okay, so I think I'm gonna commit all of the things that compile on their own, which is gonna be all of that stuff. And the Lexer file. The change to the package to include the new things we depend on. And I am going to need to include, yeah, I think everything here as well. Okay. Yeah, that's the only thing that we don't need to include in... Oh, wait, no, actually. Here, there's one thing that I don't need to include, and that's the name parser file thing. Everything else needs to be included. So token type. Yep, that change, however, doesn't need to be included as part of this. Okay, so that change is not included. Perfect. Because that's the second commit. Okay, so this is finish implementing Lexer, I guess. Not yet. We don't have... Like, I would like to switch to the proper... There's like a named formatting for like commit messages whose name escapes me, a standardization for like feature or bug fix or like breaking change. Like there's a way to like format commit in a way that's slightly more standardized. I'd like to move on to that at some point, but since now we're at the point where like half of our commits are not even gonna compile, it doesn't feel necessary at this point. Since we're just on the dev branch until we reach like a good enough point. What else did we change in this? We also changed this change also includes we removed the with location alias. We now include the file name in location. I think that's the gist of the changes. And there's one thing that's maybe probably not worth putting in the commit message is that we have not implemented all of the escape characters yet. That's I think the only thing missing for the Lexa. Good enough. And now we can introduce this, which is add Lexa debugging function that we are not going to actually need for proper compiler, but it was useful to have. Okay, there we go. I'm gonna push that. Okay. And we can go back to what we were doing. I think at this point, since the Lexa is working, and it's not too late yet, I can start making some progress on the parser itself. And I don't think we're going to be able to finish all of the parser stuff this evening, but we can make some progress. Because finishing the parser would also mean finish defining the AST, and there's so much work to do there that I don't think we're going to do that in like an hour. Okay, let's go. So now we move on to parser Y. And here I'm going to put another file. I'm going to open the grammar file that I have, which is written using a somewhat formalized standard for like grammars, just so that I can use it as reference for how we're going to implement the grammar of our language. Oh, thank you so much. I will. I don't know if you were here when I started, and I will repeat this. I really appreciate the subscriptions. You don't have to. I purposely did not do anything with like bits or anything like this because I'm not doing this project for money. I'm doing it for fun. I nonetheless really appreciate it. And yeah, Twitch continues to say that the stream is unstable, but again, the bit rate seems to be somewhat okay. Let me know if anything is wrong. I'll try to see if I can change stuff in OBS, but thank you so much. I really appreciate it. So back to here, we are using Happy, which is the parser generator for Haskell, which is like again based on like Bison or Yak for other languages. Where we're gonna basically define our grammar as like a statement, like a statement like this, and it's gonna generate a Haskell file at compilation time that is a proper LALR parser. So here we're gonna have to do two things. We're gonna have to define the grammar of our language, and we're gonna have to decide, okay, when we encounter this thing, how do we make it into a Haskell value? So let's go. A file. I'm gonna use the term file, even though my grammar here is used the term. Uses the term document. I think I prefer actually module. I think is better than file. And I'm gonna here change this is parse module, I guess. So a module is gonna be, what's the syntax? I know I can give a Haskell type at the same time that I'm doing this. Let's do this, type signatures. Okay, there we go. So that's exactly that. A module is gonna be some kind of Haskell type that we need to decide. Probably a module, that would make sense. Although those types do not exist yet because we have not defined our AST. So we're gonna have to define what a module is. And a module is made of a list of declaration. And since there's no like star and plus here in happy, we're gonna have to do this a bit manually. So it is gonna be declarations plural. And I guess here this is gonna be, rather than being module, this is gonna be make module, as in something that takes as argument. Actually, for Alex, since we didn't use any wrapper, we had the choice of how to implement those things. I think for Happy we don't. The type of those small code snippets is hard coded. Well, is decided for us by Happy. Let me quickly check that this is correct. Types. I think every time this has to be. Yeah, it has to be an expression that returns the correct type, regardless of what that is. So here. Wait, no. This is a type. This is a type. That has to be module. This is here, however, where like declarations, I can say, okay, I can associate a piece of code that, given the declarations, makes a module. And here I can say make module out of $1. There we go. Okay. Declarations is going to be a list of either import or symbol, I guess. And that way, because a module is going to be, I think we want to decompose our modules into like the set of all of the import statements, the set of all the declarations. And no, declarations are not necessarily symbols because types are not. So this is going to be either import or declaration. And make module will do something with that list to make it into a module. And a declaration is either the left recursive version when we have declarations and a new declaration afterwards. In which case, since the order doesn't matter, because I don't want the order of things in the file to matter. I want to do the same thing as Haskell, where like you can define things wherever you want in the module, and as long as they're all in scope, it's fine. I don't need here to reverse them to invert, because like with the left recursive thing, we might be passing them in the wrong order, and I think that's fine. I think it's fine to do this with the new declaration being added at the beginning of the list, which is the left recursive list of declarations. It changes the order. I think that's fine. I think, no, actually, this is not. I've called them declaration here. I'm inconsistent in my grammar between declaration here and declaration here. Oops, sorry for that. I think that's okay to be slightly inconsistent. Maybe I'll have to think about changing the name to be a bit better. Okay. So what is a declaration? That is either an import or a declaration. There again, but this time not a list, a single one. Declaration. And we have a few options. We have a use declaration, which is something that's gonna give us an import, in which case the code that we associate is just left $1, or it's gonna be Oops. Syntax highlighter is very unhappy with those files. It's gonna be a type declaration, in which case it's gonna be right, and it's gonna be some kind of wrapper. So probably type declaration of $1 or something like this. Since the AST doesn't exist yet, I'm just like making it up as I go, and we'll probably need to adjust afterwards. But this is just to give us some kind of structure to get started. And otherwise, what do we have? Oops. Extremely annoying. We have a constant declaration, which is going to be something similar, where we return a constant declaration here with whatever we pass on the left. Oh, unless actually, maybe it's going to be better for, yeah, maybe actually this is going to be this, where const decl and everything will return the proper declaration thing, and here I just give them as a right because it's a declaration. Yeah, probably better like this. Then we have a function declaration. Come on. Okay. Now let's align all of this nonsense. Okay. So we either get a use statement, which is an import, and therefore call them import. I guess they're use in our in the variables of the language. I can change this later. It's fine. Or it is a declaration of a type, of a constant, or of a function. Okay. It's going to take a while to do, but that's fine. I'm going to remove all of this. So a use declaration is going to be something that we're going to call an import for now. And a use declaration is oh, I haven't done the keywords yet. Okay, so it's going to be I think I can probably no, I have no way of doing an optional thing. That's very annoying. How do I translate this in happy? I guess I could introduce some like combinators, kinda. Like 0 or 1 of something. Would that work? No, because I have no way of giving it an argument, right? So I can't say 0 or 1 of something. Unless I can? I don't think I can do that. Precedence is something I need to handle, but that's not something we need to handle yet. Yeah, no, I don't think I can do that. That's annoying. So that means that what we're doing is going to be... So I can't translate this literally. I'm going to have to handle each case separately, I think, because... Yeah, so the first case is we have a use path, and then we have an optional qualifier, I guess. Or alias, perhaps, which is going to be a maybe thing because we might not have one. And that is going to be, I'm going to leave it undefined for now because we don't know how to handle this. I don't know what an import is made of. Or we... or we have a use path followed by this. I might have to put it between quotes, I think. Maybe not. We'll see. And then followed by a star, which means I need actually to do that. I'm going to start declaring my tokens, which is going to be... I'm going to get this full list here. Actually, I'm actually going to copy it from the Lexa. That makes more sense. There we go. I don't know for which of those the quotes are required. And for all of those, the pattern we match is a tuple that contains a location we ignore, I guess. Now we probably need to use double quotes for the operators. So let's remove that and let's put the double quotes back on the operators. And let's remove them for the keywords. Okay. And now let's close the tuples. Actually, I can do that with a regex to go a bit faster. So any sequences of spaces followed by a closing is going to be closing the parenthesis. There we go. Okay, there we go. So that should be all the tokens of our grammar. Some of them are highlighted. I don't know if they need actually a string or not. I don't think so. I think this is fine. Oh yes, we're going to need also the identifiers and literals, but I'm going to do that later. So that's good enough for now. So if we go back to this, then this is a use path followed by the token this, followed by this token. Okay. And likewise, here we're going to leave this undefined because I don't know yet what a use declaration is going to be like. We have this case here, which I think I'm going to break into more rules since Happy is very limited with, like, I can't express stuff such as repetition directly. So yeah, I wish I could use combinators, like give a... Is there a way to do that actually? Let's see. I don't see examples. Let's see if this article has something. Okay, for the tokens, they use single quote, not double quote, and they don't use anything for their identifiers. So that's what we've done is probably correct. AST, okay, passing declarations. Option. Oh, I saw something interesting. Aha! We can give parameters. Okay, so this is possible. Perfect. Let's do that. In which case, I might want to redo. Because, yeah, suddenly I can change here. This is no longer use alias. This is optional use alias, I guess. Is that the proper syntax? Optional. Yeah, that seems to be the proper syntax. I wonder if I can just like do actually as and identify. No, because I would need to specify how that's actually how that's transformed into something which that would not make sense here. So okay, so that needs to be a separate thing, but I can leave it as optional like this. Okay. So I'm gonna also use then this thing to say many and some, I think. Many of B being can I give a type signature to this? Can I give a type signature to this? Because it depends on the type of this. I probably cannot give a type signature because I don't know how to say that the type of the A value in there. The reason I chose to use Alex and Happy is because those are the standard tools that are used for a lot of compiler work. For instance, that's the one that GHC uses to parse Haskell. And as a result, they are the standard tools for the job. And I decided it was, since the goal is to actually try to, even if it's a silly project that translates a made up language into an esoteric one that is just images, I thought it made more sense to try to be as close to a real compiler as possible. And as a result, let's use Alex and Happy despite their limitations, because those are the standard tools that, again, are present in a lot of compilers. Because, again, they're just the Haskell versions of Lex or Flex and Yak and Bison. So they are the standard tools for the job, even though they have their drawbacks. I was tempted, if I didn't use Alex, to replace it with Megaparsec and just write for the Lexa where there's very little backtracking, just write a recursive descent parser in pure Haskell, because that's a lot easier to do and there is less state to keep around. Like it would be a lot easier. But at the same time, again, the goal is to try to use standard tools, hence trying to stick with this. For the same reason, I'm probably going to be using the trees that grow approach for the AST, which is an approach that was described in the 2017 paper. And I think, to my knowledge, GHC has since then started to use that approach. So a somewhat like state of the art approach of how to make ASTs, like trying to do the things the proper way, if that makes sense. But the only downside is I am not super familiar with Happy. I have used things of that nature before, but a long time ago. So it is the downside of starting a project where there are a few things at the very beginning where I'm not super familiar with the technology I'm using. But it's fine. It's working. The Lexer is working. It's all good. So yeah, here I don't know how with Happy I would be able to express. Maybe actually if I go back to the Happy documentation, do they have something about the type signature of something like this? They don't. That's fine. Let's not put a type signature here. This is correct. And then now many is something that I want more than once. Oh, yes, actually, I did not handle this case here. Here I should have like handled the empty case. This is just a Haskell comment because like it's okay to have an empty thing and to say, well, when we are out of declarations, the end of our left recursion is the empty list. And in this case, I'm going to use this instead. I'm going to say either So many of the parser followed by the parser. And that's... I'm going to assume that the order doesn't matter here, but that might not be true. Maybe because of this, I'm going to have to do this slightly... Yeah, I love parsec and all of its derivative like megaparsec. I think it's like it has a lot of upsides compared to something like Alex. The fact that you write directly Haskell code rather than writing in a weird grammar file that is a bit different and has to be translated at compilation time, like it removes this layer of additional stuff to do. It's pure Haskell code, which is very readable. Parsec is great. I love using it. But for this project, it made a tiny bit less sense, I think. When I do the advent of code, I do all of my parsing with Parsec just because it's cheating. It's too easy. It's great. I think here, since I was using the thing of like the order of declarations doesn't matter, so I can just insert them in the reverse order. But it might not always be true that the order doesn't matter. So we're gonna do this thing where for now I'm gonna use lists and gonna happen at the end of the list, which is very ugly because lists are single linked lists. Um, for big programs, this could be a problem, and maybe we'll want to use another data type here for sequences of stuff, like maybe sequence, which is implemented as a finger tree underneath. Something to consider for performance. This is fine enough for now, but maybe something to revisit later. And here we handle the case of there is actually here they did. I'm gonna do the same thing they did for the optional empty case first, where we have the empty list, recursive case otherwise. There we go. So now I can rewrite this as declarations is many declaration. I probably don't need to specify here, because here I would just be saying this, as in I'm returning the value unchanged. I think it might be fine to omit this. Okay. So here we go back to... I'm going to have to declare use alias, which is something that is not part of my original grammar definition, but that's fine. Use path that takes then those two operators and then transforms that into an import in a way that we haven't defined yet. And the third case is we have a use path. We have this operator again, this operator, and when we have a comma list of operators, of identifiers. Okay, so here I'm going to introduce a new function like this of identifier. Can I... identifier is going to be something... I need to introduce a token for identifier, and I don't know how that works exactly. That's fine, we're going to figure it out. So, comma list of identifier, followed by closing this. What's a comma list? Of some of a parser p, or the thing is going to be in this case it's a non-empty list. That's interesting. I think we're gonna have several of those that need to not be empty. Yeah, I think I'm gonna declare comma list as being non-empty always, and I will use optional comma list if something needs to be. Yeah, I think I'm going to do that. So this is either no. How do I do that? How do I express this? Because it is a bunch of things separated by commas with an optional end comma, but it could be empty in some cases. So do I want to say that even when it's empty, there is an optional comma at the end? And I probably don't want to have to deal with optional comma everywhere. It's probably easier to just use one of those functions to do it for me every time. Let me think for a second. How do I do that? So I think a comma list that can be empty will be. Actually, I could use the same thing that parsec uses and actually give the separator as an argument as well. That being said, I think I never have another separator than the comma. So maybe let's avoid making things too generic when they don't need to be. Okay, so we have an optional comma at the end, which is when it's empty. And that gives us the empty list. Or we have, God, this is going to be annoying. Or we have left recursion is preferable, but if it's left recursion, it needs to contain a comma necessarily. Hmm. Huh. Oh, actually, this is wrong here. This is a star here. Okay, so let's do the non-empty version first because it's easier. A comma list of P is gonna be one instance of the thing followed by many instances of comma then the thing, followed by an optional comma. And the result of this is going to be the first one and the beginning of the list of the second thing. And a comma list item is just always a comma followed by that one parser, and we return the second value as in the one we parsed with this argument p, which I need to give here as well. Okay, so that will parse a non-empty list of things. The empty list of things is going to be a bit different because it needs to be Well, I don't need it for now. So for now, I'm not going to bother with this, and I'm going to continue. It's a comma list of identifier, that's fine, and I'll have to think about the comma list when it can be empty, if there is ever one. In which case, I'll have to revisit this. There's probably a trick. The thing is, like, I'm not sure how to express this with left recursion, because if I do a left recursion, but I still want to guarantee that it has the comma, I guess it could be many on the left that is a That it always ends with a comma? No, that's not true. That is not true. Huh. Yeah, I'm not sure how to do this, the empty version, in an elegant fashion. I'll go back to it if I need it, because for now I don't, so let's not worry about it. And the reason I want to do left recursion is because for those kind of passes, that's a lot more efficient than right recursion and removes a lot of ambiguity, which is why I want to do it that way. So this is a use alias is an identifier, and a use alias is just, I don't need to redeclare it. It is the as keyword followed by an identifier. Okay, so here identifier is a token, but I don't know exactly what it's gonna return. Do I need to introduce? Do I need to introduce here a token, and then let me see what the documentation says. Action. Nope. Okay, so if I use... okay. So this is slightly different. No, okay. This is the value that needs to be returned. Okay, perfect. So for identifier, this is going to be matching a tuple that contains the location, and actually we will probably want to return the location as well, because we are probably gonna want to output the location as part of the AST. I'll have to figure that out. For now, this is gonna be an identifier with this. So for now, I can just say identifier, and that should work. Oops, what happened? What did I do? The fact that this file syntax is slightly off is very annoying. Okay, actually, let me just try something. Let's see. Maybe it's gonna be better now. Okay, so now we are back to this use alias is as identifier. So that should be fine. That should give me an identifier now. The imports, we haven't decided what they are, so we can't exactly do that yet, but that's fine. I'm kind of tempted to actually check a few of my assumptions. For instance, how do I extract values out of the tokens properly? Because, normally the value of a token is the token itself. Yeah. I probably want... I guess for a lot of them, actually the location is what matters. Huh. Yeah, no, actually, I think I'm gonna do something else. I think for most of them, I don't care about the value. However, for an identifier, I think most things that are important will be like the things for which we care about. Nah, for a lot of them, we actually care about the location. So maybe I should do this and let the token, the identifier terminal, always return the full thing with the location. And then I let the function that takes care of using the identifier, I'll let it handle the fact that it has actually a location. What's ugly about this, however, What's ugly about this is that means that the function that receives the identifier receives a token and have to extract the identifier out of it, which is incorrect. Is there a way? That suggests that maybe I don't want the location to be part of the like the token. I want to like do a tuple token location. Maybe I only want the location to be returned for some of the things, and that might be no. Actually, I think most of them use the location. Huh. Maybe that means instead all of my token constructors should take the location rather than it being a tuple. And that way, for the ones that have more than one value, I can extract them as a tuple. That makes more sense, I think. I might do that. The only thing is, can it be more than one value? Let's see if there is attribute counters. Huh. I am not familiar with this part of happy at all. Maybe that means there we go. I can probably do something smarter like this. Okay, so I can probably do something smarter using those attributes. That's not something I'm familiar with, however, so maybe that means I should research this later outside of the stream. And for now, I'm going to continue declaring the grammar without using the location at all, and I'll fix this after looking up how that works for next time. Okay, yeah, I think for now, I'm going to make progress on this and we won't finish it this evening, which means, yeah, I think I'm going to try to express as much of the grammar as I can, leaving for now the question of the AST representation. How do we get values and locations out of tokens, that kind of stuff. And we'll do the AST declarations, trees that grow, and all of the attributes declaration to get the locations and everything out next time. Yeah, that way I have time to do a tiny bit of research before and not just like spend time on stream reading documentation, which is fun for no one. Okay, so for now, we're going to do the same thing we did last time, which is define the right shape here and not care about the fact that it doesn't compile yet. So use alias is just as identifier, and that's perfect. No notes, all fine. And this might return actually perhaps like identifier and location or something. Like this might be different. We will figure that out next time. So now that is the use declaration done, we can move on to type declarations. So type declaration. Wait, no, I'm missing the use path actually. And the use path a use path is gonna be a list of identifiers, and a use path is going to be an identifier followed by many use path items. And the result is going to be the first one at the beginning of the list, that is the many ones. And the use path item is also an identifier or whatever we decide that identifiers should be. And in this case, it is this symbol followed by an identifier. And the value we return is the second one. Okay, there we go. Now, type declarations. A type declaration is going to be a declaration, as the name suggests, and this is going to be an alias declaration. I'm just going to use undefined there again because I don't know yet how I want to represent this in my AST. Okay, I'm just going to... There we go. Or it can be an enum declaration. Or it can be a struct declaration. Alias is the easiest. An alias declaration is I don't know yet what the type is going to be because I don't know yet if I make this a declaration or if I make it a subtype that is going to be wrapped. That's something to figure out for next time when we do the AST. For now, I'm just going to write the grammar basically in the file, and when that's done, we'll have the rough shape of it. And next time, we'll do the AST definition. And from that, from what we are trying to achieve, we'll adjust the grammar to produce the right thing. So I'm doing the busy work today, and I'll do the interesting work next time. And an alias declaration is going to be the type keyword followed by an identifier, followed by optional generic parameters, because yes, we're going to want to support that at some point in the language. The equal symbol, a type, and a semicolon, which undefined for now. An enum declaration is going to be the enum keyword, an identifier, open braces, and then optional enum items. Oh, this here, that's a possibly empty list, so we're going to have to figure that out. Interestingly, by doing this... so an empty list cannot contain a closing comma. It needs to... Yeah, that makes sense. So maybe the solution is just to say that the comma list is not empty, and to use here an optional comma list of enum item. The downside of this is that we're going to get a maybe list, which is kind of an absurd type in this case. That's fine. That's fine. Optional comma list of enum item, which is what this is. And what is an enum item? I think it's because it doesn't... I think that's what's happening. This syntax for types is not the one that Bison expects, and that's why it's very confused with some of the alignment. Well, I guess an enum item, I already know that's just an identifier. Yeah, so maybe I don't need to actually... do I need to is it better from a is it better from like a rule perspective to introduce a rule that has a very explicit name even if it's just one other rule underneath? Or is it better practice to just remove this enum item because it is going to be just be an identifier? I think I want to keep it because I might do some transformation there where like identifier gives me the location and for an enum I don't care about it or something like this. So maybe having this additional layer means here I can do some additional transformation if required. So I think it's better to leave it. Okay. So that's enums. And now we are left with structs. A struct declaration is going to be something. And it is the struct keyword followed by an identifier, followed by the optional generic parameters like this, followed by an open this, followed by struct fields, which is a comma separated list of struct field. So we can just skip this altogether. So that's a comma list of struct fields, and it cannot be empty, so I don't have to deal with the optional there. And a closing brace there at the end. Okay. What is a struct field? It is an identifier, a colon, and a type. And I guess the result is probably gonna be something like a tuple like this. Probably something like that. Okay. And I think that's all for structs. If that's useful, actually, I have made a small thing. If I look at the documentation, like this file here that I have written as like a reference for me of like what the grammar looks like. I've made something that generates an SVG out of it that looks like this, which is a big mess. It like gives the flowchart for all of the things in the grammar, like how are we supposed to parse this. I don't think I need this to implement the happy expressions, but as a reference, I think it's pretty useful. Okay, so let's go back to, I want this to be back to begin the prompt. There we go. And so struct, we're done. Now we can move to constant. A const declaration is going to be the same thing as a type alias. It's going to be very straightforward because it is going to be something which we haven't decided the type of, but it's going to be the const keyword followed by an identifier, followed by this, followed by a type, followed by this, followed by an expression, followed by a semicolon. Okay. And now, finally, last of the declarations, but far from least, functions. This is gonna be, I don't need to do that again, the function keyword, an identifier that is the name of the function, optional generic params like we have done for all of the others, followed by open parentheses, the argument, which is we're back to doing an optional comma list of something. Optional comma list of function argument, I guess. followed by closing parenthesis, followed by function return type optional. And then the function block, whatever that is, which I think just a block actually, and undefined for now. What is a fun argument? It's going to be an identifier followed by this and followed. Aha, this is interesting. This is the only place in the language in which I am going to allow the reference syntax. There isn't going to be actual references in the language. And the reason for that is, again, our target language, Piètre, doesn't have a heap, doesn't have pointers, doesn't have anything like this. It's just a stack. And giving addresses of something in the stack, it's going to be very unpleasant. So the way I'm planning to interpret reference semantics is basically just whatever part of the stack is the value is in, not copy it for the function, give the actual one so it can be modified, which is kind of reference, but not actually a pointer underneath. So that's the only place in the language where for now, I'm going to allow the reference. I'm going to allow the reference semantics. So which is why reference is not part of type, but a separate thing, just because most types otherwise, like instructors or anything, will not be able to be references. So I think here I need to introduce a fun archetype. There's a bunch of things for which, like the fact that we are dealing with a stack and no heap is going to make the representation of our project very difficult. One example I have in mind is like all structs and lists and things, where we're going to need to use several cells of the stack and therefore have like something that indicates the size of the thing and then the dynamic thing, and like copying arguments of type vector and strings to functions is going to be a nightmare. But we're not there yet, and we'll tackle those problems when we get to them. A fun archetype is going to be something we decide later. And it's going to be either a type or a reference, which we are going to likewise deal with later. And with that, we're almost done with function declarations, because the last thing we're missing is the return type, which is optional. And the return type is likewise something whose type we haven't defined yet. And it's going to be this symbol followed by a type. Okay. One thing I'd like to try to do is this will not compile in the sense of like, I'm using typed holds everywhere for the types, I'm using undefined for the things, it makes reference to types that don't exist. However, I think even if the code that it generates is incorrect, I can still run happy on the file and have it analyze the grammar, which means if I finish writing the grammar, even if what it outputs is completely wrong, even if the Haskell part of it doesn't compile, it means we can start asking it, is this grammar valid? Is it ambiguous, basically? So we can start doing some smart things. And with that, the busy work will be done, and next time we can start defining the AST and actually decide what we want out of all of those things. So that's done for functions, which means we move to the generic arguments that we have not dealt with. Generic params are gonna be... generic params is just a comma list of things. Again, because it's this symbol followed by a comma list. Interesting. Of generic param singular followed by this symbol. and a generic param singular. I could already say this is a list and this is the individual one. That is going to be... It's just an identifier, but for now I'm just going to leave it as a separate thing in case I need to do some post-processing there. That's probably the part of the project that doesn't have the most busy work. Hopefully after that, when the parser is done and we have the AST, the rest is pure Haskell code and we don't have to go back to all the busy work of listing all the rules. Next, statements. A block, which is probably gonna be something like a list of statements. A block is this followed by many statements, followed by this, and we return this. This one we can actually do despite not knowing everything yet. And the statement is either a block statement or it is an inline statement followed by a semicolon. A block statement. I think this is where some of my grammar diverges from Rust. A lot of this is like very strongly based on how Rust is defined, but here I don't have the thing where like each statement has a value and you can just like omit return in functions, and as a result I have this distinction between statements that do not have an expression, like do not have a value associated with them, versus expressions that do. So slightly, which I think is slightly simpler to implement, which is the reason why I'm doing it this way. So in many ways, like the syntax of like a syntax highlighter for Rust should work just fine on our language, but the semantics are slightly different. Block statement is gonna be probably that, just a statement. Actually, I think in both of those cases, this is just gonna be the other one. Block statement is either an, I guess, I could inline that. It's nice to have, I think, clear rule. So an if statement. A while and a for. And an inline statement, I'm just going to copy this. We have let, we have return, we have continue, we have break, and we have just an expression. Because something like the assignment operator and everything are expressions and are not specifically statements. Okay. I'm just going to copy this, actually. See if it's faster than actually doing things manually. An if statement, which is of type probably just statement, is the if keyword for an expression, a block, and an else, and an optional else statement. And an else statement is type undefined, the else keyword followed by... I probably need to break this down into another rule. This is... Copy this. There you go. What is this? Else block, I guess? And an else block. I keep forgetting I don't have to repeat this. Is either an if statement or an actual block. Because yeah, else is either followed by open braces to introduce the else block, or it's an else if. Yeah, that's the two only things we allow, I think. So this undefined. Okay, so that's an if. If expression block optional else statement. Yeah, that looks good. A while statement is a while an expression and the block. That looks good. A for statement is the for keyword, an identifier. The in keyword, that's why I have the in keyword. I was confused because I don't think I had. I saw the in keyword the other day and I was like, I don't think I do like tests of thing in list. This is where the in keyword appears. In expression with a block. Perfect. And with this, we're getting close because we just have the inline statements to do and then the expressions. And then we will be done with the busy work of expressing the grammar in happy, and we'll just have to do next time defining the AST and deciding how we translate those successful matches into AST values. Which is something for which I need to do a tiny bit more research, and therefore I'm gonna prepare that for next time. Okay. We have let statement, which is again, oops. It's the let keyword followed by an identifier followed by an optional let type followed by the equal symbol followed by an expression followed by this return statement is the return keyword followed by an optional expression. I guess that makes sense. So I'm green scope. Okay. A continue statement is just the keyword continue that we will translate some other way. And the break statement is just the break keyword that we will translate into some undefined way. Okay. What is an expression? That's the last hurdle, because this is where we're going to have to declare precedence. So let's see. An expression is going to be some expression type. That feels fairly likely to be something like that. There we go. Just gonna put a space there. An expression is a grouped expression, a path expression, a field access expression, a call expression, array expression, index expression, struct expression, literal expression, or an operator expression. Again, they're again very, very inspired by the Rust grammar. Group expression. Is just an expression between parentheses. A path expression. Okay. That is going to be how do I, is that just, yeah, I guess it's a list of path. It's a list of identifiers, which is the path, basically, followed by the optional generic arguments. This one I'm tempted to leave undefined because I'm really not sure about how... I can express this grammar thing and then decide what it means on the AST next time. That's fine. So this is going to be an identifier followed by many path expression item followed by optional generic arguments. And that's gonna also still be undefined because I don't know how to represent this yet. With the path expression item between being this operator followed by an identifier, and in all likelihood we're gonna be returning the result of the identifier. There we go. Field access is a dot. I mean, I guess those are expressions. Don't know what their representation is yet, but that's likely to be what they are. Next, this is field access is an expression followed by a dot and followed by an identifier. Transform into some Haskell value in a way that we haven't decided. A function call. Okay. Oops. I might just copy that. So all of those are very simple one-line things. I might be able to just reuse a lot of stuff. And save myself some busy work. Okay. And now just let's recheck this. Those are all expressions. For a call argument, this is... Oh yeah, okay. So of course, that's fine. This is a path expression followed by open parentheses, followed by optional comma list of call argument. And a call argument is just an expression. Yeah, that looks correct. No, undefined here. An array expression is optional comma list of array elements. Well, array element singular because that's the argument to our comma list thing. And an array element is an expression. An index expression is an expression followed by open brackets, expression, close bracket. Okay. A struct expression is a path expression followed by, this is a non-empty comma list of field expression. I have omitted the undefined in a few places. Let's put it here and here and here. And the field expression is an identifier followed by colon followed by expression. Okay. And now we're done with this. Let's go to literals, and then we have operators. We're getting to, I think we're, where are we? This file has 193 lines, and we are 122. We're more than halfway through. Half tempted to try to see if happy is already happy, as it were, with what we have before I put like 20 more minutes into finishing this. Let me do this by having literal expression be an expression that doesn't match anything. So expressions are all empty for now. And operator expression being as well. Because with both of those defined despite being empty, I think that's enough of them. Like, I think at this point there is no name that is not actually mentioned. Okay. Let's try to see what happy says if I try to run it on this file. Oops, let me put this below here. There we go. Happy. Parse error on line 92. It's missing here something, which is probably just going to be $1, I suppose. 108. Okay, so I need to always include something. Here, this is probably going to be $2. We're going to have to decide. Okay, so I cannot omit the Haskell block that decides how the thing is used. So I was right to include the undefined everywhere for now. 126. Huh. Yes, because here again, I am missing the undefined. 54. 87. 225. Okay. Unknown identifier. Okay, so there's a few things that we did not define properly. Okay. So first, why is... Oh, because here we have... Okay, so closing braces, we had a syntax error there. That's done, that's fine. Reference, that's correct. We never defined type and reference. I'm going to put them at the end for now. type is going to be something that matches nothing for now and process it with an undefined function, and likewise for reference. Multiple use of type. Oh, do I have actually... What does that mean, multiple use of type? Interesting. Is it just like it doesn't like... it probably doesn't like the underscore. Because 123, which is here, 36, which is... Oh no. Huh. I am not sure what this error means, interestingly. I have never encountered that one before. Maybe type is a reserve. No, because we're generating rules, so I don't think that's going to be the problem. But I can fix the remaining unknown identifier block statement. That is fixable. Oh, because yes, here I spelled block statement rather than using the abbreviated version that I have used elsewhere. That's fixed. Use path item. Why? Because I'm doing many use path items plural instead of many use path items singular. Fixed. Generic args. Optional generic args. Yes, I've never defined optional generic args, so I need to define that at some point. That's probably going to be alongside type. Yes. Generic args are something that's undefined for now, and it is... I can just do it, actually. It's this bracket, it's a type, it's a comma separated. It's comma separated type. Okay. And we're missing let type? Yes, let type, that's correct. For the let statement, where are you, let statement? There you are. I have made the optional let type, and the let type is this operator followed by a type. Undefined rule, comma separated. Huh. Yes, it's not comma separated, it's comma list. Unknown identifier module. But here I have module that is... Because I'm assuming module, it is this error? Huh. Okay, I still don't know what this multiple use of type means. Because I'm assuming it's not my actual type rule, because that would be weird for this rule specifically to be a problem. So I'm assuming it's my use of underscore as the type of a production that it's unhappy with, but that's weird. Did it write any of the files? If I look at grammar, no, it didn't write any of them. Huh, I'm not sure what that error is. I don't see... That doesn't mention the error. Oh, is it a problem with the token type? Let's see what lines. 23, 36, 40. So that's the first line. No, it's the second line that uses underscore as a type. Maybe that's the problem. Like if I use A here, do I get one few? No, I do get the same error. Fascinating. Oh, I know what it is. I have two different things. I have here. I understand now. I have the type keyword here, which is the keyword type, and I have type the rule here, and that's why it's confused. Okay. That makes sense. Can go back and replace this. Ah, that's annoying because I'm gonna want to change. Okay, I'm gonna change this one here because all the others have the name of the exact keyword. I'm just gonna type expression, and now let's do a thing where I replace type with type expression. I'm gonna have to decide which ones I need to replace. Nope, no. That's a type expression. Yes, that's not the type keyword. That's not the type keyword. I think at this point the type keyword is gone, so I think it should be. Oops. No, it's not all of them. Actually, I'm gonna do this slightly differently. Ah. It considers underscore as being a word boundary, so my regex doesn't work. Type expression, no, no, yes, and there we go. Okay. Now, okay, perfect. Unused rules 1. That's interesting. Unused terminals 24. That makes a lot of sense. Let's have a look at grammar debug. Rule 71 is unused. There's a bunch. Oh, there's a bunch of reduce conflicts. But I wonder how much of the reduce conflicts are caused by the fact that we have rules that are empty at the moment. Therefore, there's no way to decide how to do this. For instance, if we look at the first one, state 58. Const declaration, const identifier, type expression. Yes, I'm fairly certain that the conflict is caused by the fact that there is the type expression for now is something that matches nothing. So it has no way to know how to do this after this, I think. Because, yeah, it can, after the semicolon can reduce with rule 72 or rule 71. Let's go look at 72 and 71. Struct field, yeah. Yeah, I think the problem is the type expression being empty. I think having empty rules means all analysis of the grammar for now is going to be completely irrelevant. So that's something that we don't need to worry about. Why is rule 71 unused? Because 71 seems to be the struct one? Is it the struct declaration? Did we forget something? No, 71 is alias declaration type identifier. Optional generic params type expression. So that's the alias declaration. Why is it unused? Did they forget it? No, type declaration is here, and it points to this, which contains alias declaration, which contains this. Huh. maybe there's just a again, maybe the fact that we are using empty rules means that it's not. Oh, it has rewritten this in a. Huh, neat. And let's have a quick look at the generated grammar file, which is going to be absolutely ugly. Because for now, yeah, it's going to be a nightmare. Hello, yeah, I'm starting a new project. I don't know if you've maybe you haven't seen, like I've posted a quick announcement on social media. Basically, I'm writing. It's gonna be a long project. It's gonna take the time it needs, and I'm writing a compiler for a made-up language, which is a subset of Rust, and we are gonna compile that subset of Rust into Piètre, a esoteric language in which the source code is an image. So that's gonna be a fun project, and I'm trying to do to like, even if it's going to take a long time and it's not a project that has like a lot of practical utility, I'm trying to take it as close to a real compiler as possible, which is why currently we're using Alex and Happy for the Lexer and the parser, because you know uh, real tools for a real project. And I'm halfway done with writing the Happy grammar, which is taking a long time. The only thing is, since I have not yet decided on the AST shape yet, for now all of my grammars are just like outputting a typed hole for the type and using undefined for the value generation. It's fine. This stream is gonna be finishing soon because it's already a lot later than I thought it would be. So I'm just gonna finish writing the grammar, and next time we do the AST definition, I'm probably gonna be using the trees that grow approach for like different stages of the AST. And I will also reread the Happy documentation because I have forgotten how to properly extract values out of tokens. And I might redefine some of my token generation, token type based on that. But at least today we finished the Lexer, so we're already lexing the code properly. Yeah, I'm gonna be streaming every Tuesday and some Thursdays. So that's I've the yeah, I haven't used App Happy in a long time. So a lot of this is like I want to use Alex and Happy for this project because they are the right tools for this job. They are like the most consistent with what I want to do here. But I'm starting this project where I'm like, let's try to do something a bit educational where I write a compiler by using two tools that I'm not as familiar with as with the rest of Haskell. So it's a bit of a challenge as a start, but it's fun. The only thing is like this second half of the stream has been basically just rewriting the grammar in Happy. That has been a tiny bit. It's been a tiny bit. What's the word I'm looking for? Repetitive, probably. It is the busy work today where we just like put the rules, and next time we can actually do the interesting work, which is defending the AST. And with this, I'm almost done. I think the big problem is we have a lot of empty rules, and as a result, Happy is very confused. So, since otherwise we fixed all of the errors we have encountered, I think I can just go back to finishing writing the grammar so that we have at least something out today. So a literal expression is going to be an expression. And all of those are going to be, for now, undefined. This is going to be some of our tokens that are not defined yet. So we're going to have to add them. If I go back 2 tokens, that's the 3 we haven't defined. So we have int literal, which is going to be, for now, the tuple of location that we don't know how to extract and we don't care about just yet. And t literal int. And for now, we're not going to actually extract the value. For now, we just match. We'll fix this next time. And we have the same thing for a character and for a string. And yeah, if you were not there on Monday, the project started in a bit of a rough start because I was using the same laptop I've been using, which is like my work laptop that I have been using for years, and I use it when I stream the edit of code as well. The problem is OBS, it has no dedicated graphic card, and OBS uses like 30% of the CPU, just like flat always. Except that it's slightly warmer in this room than it was during in December when I was doing the advent of code, and the CPU got throttled because it's just running too hot. And when OBS running on the CPU for the frames gets a throttled CPU, the stream just dies. So on Monday we didn't make as much progress as I was hoping, just because my computer died midway through. So if you look at the stream history on Mondays, like 4 streams as I kept trying to restart. So now I'm using a complex setup in which the output of this laptop goes into a capture card into my gamer computer to actually use OBS on it because it has like enough like it has a dedicated graphic card and can just stream at full resolution without any problem. Despite that, Twitch is complaining that my bitrate is not constant, and I don't know why. Anyway, there is an idiom. What's the idiom in English? Like the cobbler's children don't have shoes or something. Like computer people have the most interesting computer problems. And yeah. So literals. That's basically all this is. An int literal, character literal, string literal, true or false. And then we get to. Yeah, I don't know why Twitch is complaining. Like I'm supposed to be at the. Yeah, no, you've never had weird computer problems. I've never seen you have weird computer problems. Oops. There we go. And yeah, if you're interested, I've made 2 videos on YouTube. One which is like just the project announcement that I've posted on social media, but I've made a second one which is like 10-ish minutes long that goes a bit more into details about like, why I'm doing this project, what I'm trying to achieve, what are esoteric programming languages, which I'm sure you already know, but also a tiny bit more about Pete, the language itself, and some of the strategies we're going to use to actually translate some code into an image. And the logo of the project on GitHub is itself a valid Pete program that highlights some of the structure I have in mind. Thank you. Okay, so now literals we're done. We're missing operators, and then I think there's types, and we're done. And I'll stop here for the evening because it is getting a lot later than I thought it would be. Let me copy all of this. I could try something. Maybe not. Okay, so reference expression is where I need to go back to fix the syntax. Although there's not going to be a lot of syntax to fix here, I think. Yeah, this is all correct, except I'm missing the undefined thing. And the indentation is slightly wrong, but otherwise that's all good. Oh, I'm going to need to do the precedence. Maybe I'll do that this evening, because that I remember how that works. Rather, I remember where to look for it in the oops, in the happy documentation. Okay, no, let's not try to fix this. Let's just go back and copy. Okay. I don't think my microphone is capturing this. There seems to be some merriment outside. Okay. So this is all missing the undefined because the the rule for how to translate the match into a Haskell expression has to be there everywhere. So I think that's missing on all of them. But I think otherwise this is all correct. No, here as is not with quotes like this. That's wrong. I guess I could have made the keywords using double quotes just to make them very clear. Maybe they would have actually avoided my type conflict I had earlier. Maybe I should have kept double quotes for the keywords. Oh well, too late now. I mean, too late. Could change it, but okay. So that's all of our assignment, all of our operators. Assignment, compound assignment, range exclusive, range inclusive, cast, boolean, comparison, arithmetic, negation, reference. Okay. And now for all of them, we are going to need query replace. I don't even know. I don't need to do that. Let's do every new line replaced by undefined new line. And no, yes, no, no, yes, yes. Okay, there we go. And with that, we're almost done. A reference is just this symbol before a type expression. A type expression is... It's just a path type. Why did I break it into this? Huh. Why did I break it into those two things when I wrote the grammar? I don't remember why I did that, and I might not need to do that. What's a path expression? Oh yeah, of course, it's a series of identifiers. But there's already the generic arguments here. So why are the generic arguments... This is very wrong. This is very wrong. So what's the difference between a path expression and a type? I think the difference... No, it's the same thing. I don't think there's a difference there. So I don't know why I have... Maybe I want them to be distinct just in case there is a difference in how I translate them. Yeah, and that might be the only reason why I want to separate them, is just because maybe the translation will be different when for a path expression where I'm calling something, I'm making a reference to a symbol with some generic arguments. That being said, this is the same thing. A type here is just I'm making a reference to a symbol with some generic arguments. Maybe I could... The thing is, however, a path expression is an expression, and that's not what I want here. So maybe I should... I'm just going to duplicate this. That way I have more freedom for how I arrange my type at a later point. So a type expression is going to be this identifier, many. Oh, that means, however, that it might be ambiguous between different... it should be fine. Okay. So now that's the entirety of our grammar. We're missing one thing, which is, and I'm going to remove this and go to the reference, because I want to go to operators. Here is... Where's the precedence? Precedence. There we go. So that's the precedence, which I think I have... I think in the documentation for the project, I do have something. Would it be in the reference itself? Yes, I have this very, very large image. Can I open it in a new... That work? Nope. Okay, I have no idea how to open it into a new thing, but basically like how a how to pass a complicated expression for precedence. So here, okay, so that tells me how to pass different things, and I just need to quickly look at the happy documentation. Here, for precedence, I remember that it is a series of things at the top of the file using happy, using precedence. There we go. Okay, so where is that? That is in the header. Okay. So I can just say which associativity the thing is, and they are in order of... Okay, so the ones at the bottom are the ones that are supposed to match first, since multiplication is here before, like at the after addition. So if I go back here, I can specify. So here at the very bottom will be the non-associative. Well, path expressions don't need to actually be... I don't think I need to specify that. Range expressions, however, will be at the very bottom, and they're not associative. So they go here. Then we have the Boolean operator. What did I say? Grouped left to right. That's left. I don't know why it's doing this annoying thing with the indentation. So here that's going to be or Boolean operator. Wait, no, that's the one that's the one that binds, the one that's the bottom of the list in happy is the one that binds first, which is the other order from this list. So I need to do this the other way around. This needs to be at the very top. I remove all of this empty space that it keeps wanting to add for no reason. God. Okay. So Boolean first range operators, you are at the very top of this list. Then or and perfect. Next we have comparison operator, no grouping is performed, parentheses are required. That means they're non-associative. I'm very happy I wrote all of this before, because now I don't have to think. I can just do whatever is listed here. That also includes... Oops, what is happy doing? Oh, it's jumping. Can I just deactivate the Bison mode of Emacs, because it is... No, I don't seem to be able to deactivate it. Okay, that's fine. Okay, so that's the comparison operators. Then if we move up, that's plus and minus. Just gonna copy them here, and we are using double quotes instead of single quotes, but that's fine. Then we have multiplication, division, modulo. Then we have the power operator, which I'm using differently from Rust. This is the XOR in Rust. I'm using it as the exponentiation operator in this language. Then we have the as operator. I'm not sure why it's associative, but I guess that makes sense. Yeah, no, I guess that makes sense. If I want to like do several chains of conversions between types that are compatible, even though I don't think it's gonna be a thing that really exists in that language. But I guess that makes sense for it to be left associative. Then unary operators. Aha, this is where I need to. There is a syntax for this. There is a syntax for this. There we go. Here I can define a specific precedence for. Huh, wait, it binds? Yes, it binds more than. Yes. Um, so here I need to do. Well, I guess no, those are left associative as well. And here, this is where I'm going to use a rather than actually listing the thing, I'm saying at this level of precedence is now the negation thing. And here I can use in the negation thingy. There we go. For those, I can say that those are using the precedence of the negation. I don't know if I should put it at this level. I don't know if I should put it at this level or if I should inline everything. We'll see. I'm going to try this and we'll see. Okay. Next. I guess I'm going to actually rename this as unary. Because the reference operator is also using that. This won't be perfectly aligned. That's fine for now. And then after that, function calls, field expressions, all of those should be. All of this should be unambiguous. I don't think I need to use. Maybe I'll have to add more here for the remaining things that don't have like a clear operator, a clear rule, basically. And maybe instead of actually using the operators, maybe I should use like named precedents for everything and then put named precedents everywhere. That might make a lot more sense. Okay, but now let's just run this. Okay, no. Oh, thank you. Yes, you're right. Where are they? Oh, in the comparison operators. Yes. Thank you. Okay, unused terminals. What's the unused terminal? That's a bunch of shift reduce conflicts, but that's not too bad. There is no longer a reduce conflict. That's good. Aha, terminal use is unused. And that's probably because here in my. Yeah, the only thing that I'm not sure about is the fact that I have like a layer of indirection rather than having all of my operators being at the expression level here, where I can decide, oh, this is all of my operators and therefore here's all the precedents. I have like grouped under arithmetic comparison Boolean, and I don't know as a result if I should put the precedence information here with a named precedence so that they're all listed at the same level of the gamma, or if listing them the way I've done is enough. Probably fine. We can't really test right now, given that I don't have an expression type, and also it's late. But next time, I think I'm going to start with this. I will do the expression type first, so that we can try passing the expression part of the grammar first to make sure that the precedent is correct. I think I'll do that first. Also because expressions are going to be probably the easiest part to represent in the AST, or at least easier to get something out before we figure out the trees that grow representation approach and all the location stuff. And yes, the use thing is. I've missed something. I think it's because the use path, I forgot that the use keyword is supposed to be used. If I go back to the grammar. Ah, that's because I've merged the use declaration with the use tree. There we go. So this is a use tree whose type is undefined because I don't know what it's going to be like. I guess it's going to be an import. But the use declaration is the use keyword followed by a use tree followed by a semicolon, and it's going to be the second thing that we parse here. Okay. There we go. No longer any unused terminal. 381 shift reduced conflicts, but no longer any reduced conflict. That's a pretty good sign. Okay. If I try to compile this, it's going to be a complete nightmare. But let's do it for the fun. Just to see if there's anything obvious we can fix before we stop here. Yep, nope, that's going to be the errors in the happy generating module are gonna be unpleasant to debug. But I mean, a lot of it is just like I make references to type that don't exist, or yeah, all the states. I mean, it's the whole thing of parcel generators, right? Like they generate something very very efficient at the price of readability. Hence the reason why we're using another language for that. Okay, well, I think I'm gonna stop here. We still have accomplished, we have a lexer that works, uh, despite the limitations of Alex around Unicode, and despite having to do some very, very ugly thing to parse Unicode code points, given that Alex works byte by byte and our identifiers can be any letter. Ah, nice. Yeah, no, this is I've had some errors in the file itself, but I think the errors now are not happy errors at generation time. Happy is perfectly happy generating, if I may say so, generating a Haskell file. It succeeds, and then the Haskell file doesn't compile because of all of those things are completely wrong. So the grammar is perfectly fine. The Haskell blocks, however, completely wrong. Okay, but that's gonna be good enough for today, I think. Why do I have lenses in here? That's probably... I don't think I still use lenses in here, so I can probably remove that import. And do I still have the text? Yes, I do the take here. Okay, so I need to keep this. Okay, well, perfect. I'm gonna commit this, and I'm going to stop here. What did I change here? The use path was wrong. Oh, that means I should probably regenerate the grammar. Ah, that's annoying. That's probably my makefile. My makefile is wrong, actually, probably. Huh, interesting. A stack run of a specific... A stack run of a specific program that does not depend on the library still fails when the library doesn't compile. That's interesting. Okay, so I'm just going to do this manually. Okay. Oh, it's not happy. What didn't work? Huh. What is wrong? Oh, because the syntax here is incorrect. Yes. There we go. Okay, so I have regenerated the grammar SVG, which means I can regenerate the SVG file. Oops, that's not correct. There we go. Because there was a difference. Here I had an optional identifier instead of many identifier. I was wrong. So I've replaced this, which means now I have a slightly different SVG thing. Since my generation thing makes, yeah, it's going to be a bit unreadable because it just enumerates them. Yeah, okay, so that's going to be unreadable. That's fine. Let's commit this as like fix error in grammar documentation. And finally, okay, and there we go. And with that, I think that's gonna be all for today. We've fixed Alexa, we've implemented all of the grammar rules of the grammar, and it seems to not create any reduce conflict, so that's good. That means it's not too ambiguous. And that means next time what's left of the parsing stage is, well, we're done with the busy work at this point mostly. Now we just need to define the AST, define like the trees that grow approach, which is going to be a very interesting occasion to talk about some type level shenanigans, such as type families and doing that kind of stuff. That's going to be fun. And data kinds and all of that good stuff. And yeah, next time we can start parsing some files. But with this, I think I'm gonna stop this evening because it's already, it's almost midnight here. I meant to stop at 11, so yeah. Thank you for tuning in. I hope this was interesting, despite it being slightly repetitive towards the end. And yeah, I'll see you on Tuesday. See ya.